Okay, welcome everybody. In this video, we're going to continue working with ggplot2. We're going to take a look at some of the more, um, I don't know, advanced features, or at least dig a little bit deeper beyond the basics of ggplot2. And we'll take a look at faceting. And so faceting a ggplot creates separate panels for each level of one or more categorical variables. So faceting works with categorical variables. It also will work with discrete numeric variables. It does not work with continuous numeric variables. So just keep that in mind. It's really most appropriate when we're dealing with categorical variables that are being stored as factors. So there are two types of functions that can be used to create faceted graphics in ggplot2. There is the facet wrap, which creates facets based on a single factor variable. And the panels are wrapped around the plotting window. And I will say this is typically the more useful type of faceting. And there's also a facet grid, which forms a matrix of panels based on a row and column of faceting variables. So let's first take a look at wrapped faceting, which again is probably the more commonly used type of faceting. And we're going to stick with the same example that we've been working with, so we don't have to kind of process new type of information, and we can just focus on the faceting side of things. So we're going to work with the penguin's data frame and a scatter plot of body mass to bill length. So body mass is on the x-axis and bill length is on the y-axis. So if I don't use any faceting, I'm just going to comment this out. I think it might run if I have a plus sign there. No, it doesn't. So I'm going to comment out that extra layer. So if I don't add a facet, I just have that layer. And we've seen that, okay, there's this like little noise in the upper left corner, and that is due to the fact that this is a separate species that we have in the upper left corner. And one way that we were able to identify that was by mapping the species to a different aesthetic, such as color and or shape. Another way that we might be able to identify that would be by faceting. So the function for wrapped faceting would be facet underscore wrap. And I would just put a tilde and then the variable that I want to facet. And again, this variable should be a factor. And species is a factor. I have 3 species, so it's going to create 3 different panels. The first panel is for the Adelie species. The second is for the chinstrap, and the third is for the Gen 2 species. And so this is just another way of looking at these 3 plots that we can accomplish kind of a similar goal as doing mapping to the color aesthetic. So this was another way of trying to see, okay, is there some connection between, this cluster of points that we saw up here in the upper left and species? Here's another way of getting there. And you can think about what are the pros and cons of these 2 different methods. And when we do a facet wrap, it's important to note we can see it on the vertical axis. It uses the same scale on the vertical axis. It doesn't even indicate a scale on the vertical axis for the middle and the rightmost plots. It's implied that it's using the same scale on the y-axis. And we can see, looking at the values on the x-axis, it's using the same scale. And that makes sense if we're comparing these 3 different sub categories that we probably by default would want to compare them on the same axes, on the same scaled axes. If we change the scales, then that changes the slopes, or at least the look of the slopes, and that might be misleading. I will say, there very well may be situations where you want to change the scales to be different on different axes. And so you do have the ability to customize things. So for example, if I want the scale on the y-axis to be different because these points, the Adelie species, have a very different distribution of bill lengths, for example, than the chinstrap and Gen 2, which are very similar distribution of bill length values, at least. I can set free the scales option of the facet wrap to free Y. And now you can see how this might be misleading. So if I don't actually look at the scale values, this would seem to indicate that all three species have similar distributions of bill lengths. But if I actually look at the values, I can see that the Adelie and Chinstrap actually have very different distributions. So this one ends at about 45, and this one begins at about 45. So like these are quite different. And I can see that much more clearly over here than I can over here. So you can customize these. It's just something to be aware of, and something that I don't think you want to do by default because it can be misleading. Okay, so I will stop this video here and we'll talk about grid faceting in the next one. Thanks.